In the previous video, I told you that electrochemical reactions are often called redox reactions because of the reduction and the oxidation that takes place. And so today we're going to get into what oxidation and reduction actually mean. The key thing about this is making sure that you keep your definitions straight, because if you get the definitions backwards, then it leads to all kinds of other problems. So I'll give you a couple of memory tips for trying to remember which one of these is which and which ones are associated with what in order to help you keep it straight. Okay, and then I'll do an example to kind of flesh all that out for you. So in an oxidation reduction reaction, or in any type of electrochemical reaction, you have to have both oxidation and reduction to take place. You cannot have one without the other, because in oxidation, you have electrons that are lost, and then those electrons are gained in the process called reduction. Now, I realize that that sounds backwards, because usually if you reduce something, you're not gaining, you're losing something, okay? So that can be the tricky part of keeping these definitions straight. The mnemonic that he gives you is Leo says GER, where this stands for losing electrons is oxidation. So it's L-E-O, losing electrons is oxidation, and the GER is gaining electrons is reduction, G-E-R. Gaining electrons is reduction. Now, honestly, the way I tend to think about this is that the atom or the element that is reduced is the one that is going to go down in charge. Okay, so it's going to go down in charge. Its charge is reduced, or its oxidation number is reduced. In fact, again, I should probably put goes down in oxidation number. Again, they're not true charges, but because of the way we write them, I think that, at least in my mind, I tend to equate the two of them. And like I mentioned in the video before, a charge and an oxidation number are not the same. And so I do apologize when I tend to flip my terms around, because it's kind of stuck in my brain that way. And I know a lot of students have that same thought. It's not really a charge, it is an oxidation number. So if you're going to go down an oxidation number, that is a reduction because you've gained electrons. So again, we'll do an example here in a second. The element that is oxidized is a part of the reducing agent, and the element that is reduced is a part of the oxidizing agent. So the oxidizing agent is going to cause the oxidation to happen. And as a result, the thing that is left behind is reduced. So again, I think it's become a little bit more clear once we look at an example. This is example 9.2. And what he asks you to do is to prove that this is an oxidation reduction reaction. Is it actually a redox reaction? Not every reaction is a redox reaction, because if you would go through and assign oxidation numbers to everything, you would find that the oxidation numbers stayed the same all the way through the reaction. Is that the case here? Well, let's go through and let's assign these oxidation numbers like we learned in the first video. So here we have hydrogen peroxide, and we learned yesterday that hydrogen peroxide is an exception to the rule. We learned that the hydrogen has an oxidation number of a +1, and that in hydrogen peroxide only, the oxygen has an oxidation number of a -1, okay? The chlorine is by itself, and there's no charge written on it, so it's going to have an oxidation number of 0. Then when I get over here, I've got hydrogen chloride. Well, again, the hydrogen, it's not with a metal, so the hydrogen is going to have an oxidation number of a +1, and that means the chlorine is going to have an oxidation number of -1. And then over here, the oxygen is an element that's by itself. There's no charge written on it, so the oxidation number for it is going to be 0. Okay? Now, maybe you'll be able to see why I personally make it a habit to write my oxidation numbers up above, and that's because I can now easily track what's going on. So if I look at the hydrogen has an oxidation number of 1 on this side, and it has an oxidation number of 1 on this side. So here, I don't have any kind of a change in my oxidation number, okay? You don't have to write all of this out, by the way. I'm doing it just to make it more obvious as we're going through it. I don't expect you to write it out. You'll just be able to look at it and tell. My oxygen on the left side has an oxidation number of a -1, but on the right side, it has an oxidation number of 0. So here my oxidation number has changed. What's happened to it? Well, it went from a -1 to a 0. How did it do that? Well, the only way it could do that was for it to lose electrons. And so if it loses electrons, that means that it has been oxidized. Okay? It actually went up in oxidation number, so it has been oxidized. Now, what happened to my chlorine? The chlorine on the left side had an oxidation number of 0. On the right-hand side, it had an oxidation charge of a -1. That oxidation number has gone down. And so because my oxidation number has gone down, that element has been reduced. Okay, so this is where I use this definition to help me figure out which element was oxidized and which was reduced. Which one actually went down in oxidation number? Well, 0 to a negative number is going down, so that's reduced. This one went up, so this one was oxidized, okay? In order for it to be a redox reaction, one element has to be oxidized, one element has to be reduced. You cannot have one without the other. It is impossible. And if you find a reaction where you have just oxidation and no reduction, or just reduction and no oxidation, it probably means you made a mistake someplace and you need to go back and check your oxidation numbers again, okay? So, hydrogen is not involved as far as being oxidized or reduced because its oxidation number never changes. The oxygen has been oxidized, and so that means that hydrogen peroxide is the reducing agent. Okay, it's causing the chlorine to be reduced. Similarly, the chlorine is a part of the Cl2, so Cl2 is the oxidizing agent. Because of what's going on with the chlorine, it is causing the oxygen to be oxidized. So it's called the oxidizing agent. Now, I do want to point something out here, and that's that the answer key for your textbook is not consistent. Sometimes he will say oxygen is oxidized and is the reducing agent, and chlorine is reduced and is the oxidizing agent. What I want you to do instead is to say this oxygen is a part of the hydrogen peroxide. The hydrogen peroxide as a whole is the reducing agent. And the chlorine, while the oxidation number on the chlorine is being reduced, Cl2, which it is a part of, is the oxidizing agent, okay? So when you tell me what the reducing and oxidizing agents are, I want you to use the entire molecule that is a part of and not just the atom itself. So on your test too, make sure that you use the entire molecule that's involved. You'll tell me that one particular element is being oxidized or reduced, but then you're going to use the entire molecule for telling me what the reducing and oxidizing agents are. You will see, again, in the answers that he kind of flips back and forth. Sometimes he'll tell you that this is, and sometimes he'll tell you that just the atom is, okay? But this is what I want from you on your test, so make sure that that's what you get in the habit of doing when you do your homework, all right? So that is oxidation and reduction.